Solving systems using the elimination method. Here's a breakdown of what the method is about. You're combining the two equations in your system by either adding or subtracting them in order to eliminate one variable. If the signs of the variable you're trying to eliminate are the same, that means two positives or two negatives, then you're going to subtract. If the signs on the variable you're trying to eliminate are different, one positive, one negative, then you add. So here's solving a system using the elimination method. The first thing I look for is for matching numbers on either one of the variables. When I look at the x's, there's a 1 in front of this x and a 2 in front of that. That's not a match. When I look at the y's though, there's a 1 in front of the y and there's also another 1 in front of the other y. So this is the variable that I'm going to eliminate. So I'm going to rewrite my problem down here. Draw a big line underneath. And remember what the note said. Since the y's are the ones that match, look at their signs. Are they the same or different? Remember, if they're different, then you're going to combine these two equations by adding them together. Okay, adding them together is going to eliminate the y's, but we should keep everything else when we work this problem. So what's x plus 2x? 3x. Y plus a negative y is 0, so that's gone. And then what's 2 plus negative 5? Negative 3. Okay. Now I need to finish solving for my problem. So I'm going to divide by 3 on both sides. And x comes out to be negative 1. What do you do once you find the value of one of your variables? Plug it back into one of the originals. So I'm going to choose number 1. I'm going to add 1 to both sides. And I get y equals 3. So my final solution for this is negative 1, comma, 3. Here's another problem where we solve the system by using elimination. Again, the first thing I look for is for a match. Both of these have a 5, even though they're different signs, they both have a 5 in front. Okay, and I'm going to combine them by adding or subtracting. Hopefully you said add, because the signs are different. Okay, so that means the x's will eliminate. What's negative y plus 2y? Positive 1y. And then 5 plus 0 is 5. Okay, so we already have our variable for this one. It's already solved for us. Y equals 5. So you take this and plug it back into one of your originals. Okay, so this is really just 5x minus 5. I'm going to add 5 to both sides. And then I'm going to divide both sides by 5. And x comes out to be 2. So our solution for this system is 2, comma 5. Here's another problem. If you look at this problem very carefully, you'll find that neither the x's match nor the y's. And if nothing matches, how are you going to eliminate? Well, you have to make them match, okay? That's going to take some multiplying. You can either decide to make the y's match up, or you can decide to make the x's match up. In my case, I'm going to choose to make the x's match, because I know that I can multiply this by 3 to make it match that one. However, if you're going to multiply the x by 3, everything in the equation has to be multiplied by 3. Okay? So I'm going to write my new equation down below. So 3 times x is 3x. 3 times 4, 12y. 3 times 16, 48. And then I'm going to rewrite my second equation down below. Am I going to add or subtract my two equations in order to combine them? Same sign, so we're going to subtract. So 3x subtract 3x is 0, it's gone. 12y subtract 5y is 7y. And 48 subtract 20 is 28. I'm going to divide by 7 on both sides, and y comes out to be 4. Okay, remember, what do you do when you get one variable? Plug it back into the original. Subtract 16 from both sides, and you find out that x equals 0. So your final solution for this system is 0, 4.